Suppose that z is a function of r, s, and t, such that r is a function of c, that s is a function of b and c, and that t is a function of a, b, and c. Now we want to use a tree diagram to write down the chain rule formulas for the following. So we want to find the derivative of z with respect to c. We want to find the derivative of z with respect to b. And we want to find the derivative of z with respect to a. So in this example, we're given everything that we need. We have the original function z, and we have the parameterizations of the three independent variables found in the function of z. So we can go right ahead and start to create that tree diagram. So remember, with your tree diagram, the first thing that you want to do is connect each variable with a line where each line represents a partial derivative. So again, we are starting with the function z, which is a function of three independent variables, r, s, and t. So at the top of our tree is the variable z, and now z is a function of r, s, and t. Now each one of these independent variables is parameterized by one or more parameters. So starting with r, we see that r is a function of the parameter c. So it only has one parameter, one letter underneath it, one variable. Now the function s is a function of two parameters, b and c. So underneath s, we have two variables, b and c. And last but not least, we have that t is a function of three parameters, a, b, and c. So underneath t, we have three additional variables, a, b, and c. Now, to define the chain rule, we need to connect each variable with a line. So we have the line from z to r is the partial derivative of z with respect to r. The line from r to c is the partial derivative of r with respect to c. So that branch is done. Now moving to our middle branch, we have the line connecting z to s is the partial derivative of z with respect to s. And now we have two lines coming from s. We have a line from s to b, which represents the partial derivative of s with respect to the parameter b. And we have a line from s to c, which represents the partial derivative of s with respect to the arbitrary parameter c. And that branch is done. So moving to the right-hand branch, the line connecting z to t represents the partial derivative of z with respect to the variable t. And then we have three other branches. We have a line connecting t to a, which is the derivative of t with respect to the parameter a. We have a line connecting t to b, which is the derivative of t with respect to b, or the partial derivative of t with respect to b. And then last but not least, we have the line connecting t to c. So this line represents the partial derivative of t with respect to c. And so here is our tree. And we're now going to use this tree diagram to find three different derivatives based on the three parameters. So here we go. Let's start by finding the derivative of z with respect to the arbitrary parameter c. Or we can use our subscript notation, z sub c. Now, this derivative is most close to the definition that we've been looking at. And that's because if we look at our tree, we can see the parameter c is a parameter for each of the independent variables. So, let's see. The derivative of z with respect to the arbitrary parameter c is defined as follows. So starting at z and the left-handmost branch, we have the partial derivative of z with respect to r multiplied by the partial derivative of r with respect to the arbitrary parameter c. Now, moving to our middle branch, we have the partial derivative of z with respect to s multiplied by the partial derivative of s with respect to the arbitrary parameter c. So you have z sub s multiplied by s sub c plus, moving to the right-handmost branch, we have the partial derivative of z with respect to t multiplied by the derivative of t, or the partial derivative of t with respect to the arbitrary parameter c. So we have plus z sub t multiplied by t sub c. So there we have it. This is the derivative of our function z with respect to one of the arbitrary parameters, c. So now we are ready to find the next derivative. We want to find the formula for the derivative of the function z with respect to the arbitrary parameter b. Or we can use our subscript notation z sub b. So now looking up again at our tree, we can see here that the parameter b only shows up for the function, or for the independent variable s and the independent variable t. So we can ignore the branch that contains r. So here we go. We have the derivative of the function z with respect to the arbitrary parameter b. So starting with your middle branch, we have the partial derivative of z with respect to s multiplied by the partial derivative of s with respect to b. So the partial derivative of z with respect to s multiplied by the partial derivative of s with respect to b, plus, moving to the right-hand branch, we have the partial derivative of z with respect to t multiplied by the partial derivative of t with respect to b. So that's plus the partial derivative of z with respect to t multiplied by the partial derivative of t with respect to b. And now I've been using my subscript notations, but of course keep in mind that you can use your differential notation, dz ds multiplied by ds db plus dz dt multiplied by the derivative of t with respect to b. Both answers are beautiful, and they mean the same thing. So this is our answer for the derivative of the function z with respect to that arbitrary parameter b. And we have one more to go. In case 3, we now want to go ahead and find the derivative of z with respect to the arbitrary parameter a. So z sub a. Now again, looking up at our tree here, we can see that the parameter a only appears for the independent variable t. So we only have one branch to move along. So we can say that the derivative of z with respect to our arbitrary parameter a is defined, again, starting at z. We have the partial derivative of z with respect to t multiplied by the partial derivative of t with respect to the parameter a. So that's the partial derivative of z with respect to t multiplied by the partial derivative of t with respect to a. Or again, you could use your differential notation, dz dt multiplied by dt dA. And so there you have it. Here are the 3 different chain rule formulas for the 3 different parameters of our functions.